Hey friends, welcome back to another video. It's me, Ashol the Brilliant, and you're watching Learn with Ashol. And today we're going to be studying sequences and series. And it's a new topic, so let's get started. Okay, so the first thing that we're going to learn is a sequence. So like, what is a sequence? A sequence is an ordered list. So a sequence is an ordered list of numbers. Let me just there we go. So examples of a sequence are like example number 1, we have 1, 2, 3 going on and on and on, right, forever. Then we have example number 2 where we have 2, 4, 6, 8, 10, 12, 14. Okay, the one thing to know is that you can see there's like this pattern, right? Like there's this order like we said earlier. So like it's kind of easy to guess the pattern, especially in these like simple examples that I'm giving over here. We have like 1, 3, 5, 7, 9, on and on. We have like 4, 8, 12, all the way to like 44. And let's take one more. We have 5, 10, 15, 20, and 25, on and on forever. Okay, so we have like 5 sequences, right? These are like simple examples. And yeah, like let's move on to the next step. So the numbers inside these sequences, they are called its terms, members, or elements. So the numbers in a sequence are called its members, terms, or elements. So there we go. Now, like for example, let's take example number 5, right? So in this example, 5 is the first term, like first term. Then we have 10. 10 is the second term, and 15 is the third term. Okay, so you get the idea, right? Like it's the same for 20. 20 will be the fourth, 25 will be the fifth, and it's like the same thing for the other sequences too, like 4, 8, 12. 4 is the first, 8 is the second, 12 is the third, etc., etc. Like 44 is the 11th. So yeah. Now the sequences that we've like made over here, these sequences, they can be named using lowercase letters. So sequences can be named using lowercase letters like A, B, C, stuff like that. So there we go. Okay, so now let's name so the series that we the sequences that we listed, that we gave examples as. So I'm going to name this first one this sequence in the first example, A, B for the second, C for the third, D for the fourth, and E for the fifth. Okay, so the letter N is used as a variable. The letter, instead of like, you know, the traditional X, Y, Z type thing, we use N. The letter N is used as the variable, and its value, you could say, determines or like shows / tells the position of a member / term. So yeah. Okay, so the letter N is used as a variable, and like how it works is, if I have the first sequence A, right? I have 1, 2, 3. So like 1 is the first term, and it'll be like A1, right? Like the sequence's name is A, so its terms will be like A1, A2, A3, all the way to AN, right? AN is some term that we don't know, whose value that we don't know. So like, I'll take 1. 1 will be A1. 2 will be A2. 3 will be A3. EDC, right? Like for this one, this keeps on going on. For this one, it'll be B1, B2, B3, right? But like this one won't go like on and on. This one will stop. Why? Because we have a limited, you might have noticed that there are like these dots in some of the sequences, right? In some of my examples, like A has it, sequence C has it, E has it, D and B don't, because we're trying to show that we know where it ends, right? We know the end term of those sequences, B and D. So for this one, it'll be like B1, B2, B3, all the way to B7, because you probably noticed the pattern. So yeah, it'll go up until 7 terms. For this one, it'll be C1, C2, C3, but it'll go on, like on and on forever, I mean, right, because you can see the dots. For this one, it'll be like D1, D2, D3, all the way to D11. And finally for this one, it'll be like E1, E2, E3, all the way. Okay, so that is done. Now, one more thing that we'll talk about is, well, those dots, right? We just talked about it, the on, and some of them don't. So why is that? That's because there are different types of sequences, right? Sequences can be finite or infinite. Sequences can be finite and infinite. And what does this mean? Oh, get it. Yep. Okay, so what does this mean? Let's define them, right? So finite sequences first. Finite sequences are sequences whose last term is known. For example, sequences B and D are finite since we know their last terms are 14 and is 44. So yeah. Now, another way to define finite sequences, actually, we'll get to that in a bit. Sequences whose last term is unknown are called infinite sequences. For example, sequences A, C, and E are infinite since we don't know their last terms. Okay. Now carefully gonna stretch it out before clicking outside. Okay. So these are infinite sequences. Okay. So we can come back here. You can see A. We know don't know actually. We can't see like an end. We can see an end to B. We can see an end to D, but not C and E either. So we know which ones are infinite. Infinite ones are A, C, and E, and the finite ones are B and D. Now we are going to look at sequences in from a different perspective, you could say, right? Because it's always good to look at things from a different perspective. So let's say we can say a sequence can also be defined as a function. You recognize what this is, guys? Yeah, I don't think so, right? I mean, even if you do, I think we should just review a little bit on about functions. So let's talk about functions. What is a function? A function is a relationship, a rule, you could say, or a law between two variables where one variable is independent while the other is dependent. So okay, so there we go. That is a function. That is a quick recap of a function. Now let me just give you an example of a simple example of function is like y is equal to 3x, right? This can also be written as what did I do? Make that right. F of x is equal to 3x. It's the same thing. F of x or y, whatever you choose. So y is the dependent variable and x is the independent variable. And what this means is that if we put in a value for x, we'll get a value for y. Let's see how this goes. If we let x equal 1, then y will be equal to 3 into 1, which will be y is equal to 3. If x is equal to 2, then y will be equal to 3 into 2, so y will be equal to 6. Similarly, let's get one more. If we, what am I saying? If x is equal to 3, then from this function, y will be equal to 3 into 3, which will be y is equal to 9. So I think this is enough. We can go on and on if we want, but we want to stop it right here. And we want to take a look at the values of x and y, right? So when we put in the value of x, if we put 1 as the value of x, then we get y is equal to 3, or 3 as the value of y. For x is equal to 2, we get y is equal to 6, right? So the values of x, the values we put in for x make up the domain of the function. Like, basically, we should say the set of the values we put in for x make up the domain of the function. Right, so what we did, we put the value of x as 1, we put it as 2 and 3. So what this means is that the domain of the function is equal to the set of values. So those like values of x for this function, which will be equal to 1, 2, 3, on and on and on. So we can kind of like, we can make a set if we want. I don't think it's like necessary. Oh, well, yeah, I guess that's okay. Okay, now similarly for this, like the set of values we get for y make up the range of this function. Okay, so let me just stretch that out as well, please. Okay, so the range is equal to values of y is equal to 3, 6, 9. Okay, one more thing that you might have noticed in this function is that whatever the value of x is, y's value will be 3 times that, right? So like, since x's value is 1, it's 3. X's value is 2, it's 6. X's value is 3, it's 9. So yeah. Okay, anyway, I think this is enough for a review on functions. Now let's get back to our sequences and series, our topic of the day. So now let's redefine sequences, or let's define it in another way. A sequence can also, be defined as a function whose domain is a subset of the set of natural numbers. This means n is equal to, let me find those braces, this one, 1, 2, 3, on and on. Yeah, so let me just stretch this out. Okay. And sometimes the domain can be taken as the subset of the set of whole numbers where you could say like the values start from 0 instead of 1. Okay, so yeah, this is another way to define a sequence. So like in a sequence, basically, like, you know, the f of x that we, like in functions we use like y or f of x. In sequences we use the variable n, as we already said, right? So like it might, for like a sequence, it should be something like this, right? But what we do is, instead of f of n, we use an, right? So an is basically like f of n, or f of x. It basically means that. And like whatever the domain is, domain we already said is like a set of natural numbers, right? So it'll be always be like 1, 2, 3 something something, like a subset of that, right? Like 2, 3, 4 or something like that. Like we gave the examples of the sequences like above. So like okay, so now we like know that the domain is a subset of the set of natural numbers, right? So let's say like in the domain, like the first value, like whatever the value in the domain is, that's going to be like the value of n, right? As it's the variable. So like that's like the input. So if, for example, n is equal to 1, right? The domain is 1, 2, 3, and we say like for like n is equal to 1, we'll get a value, right? That value will be the first term of the sequence. So like the output is actually like the sequence. We have the domain, which is like the input, and we'll get an output, and that output will make up the sequence. So for n is equal to 2, we'll get the second term. For n is equal to 3, we'll get the third term. For n is equal to n, somewhere down the line, well, not right now, but like somewhere down the line, we'll get n is equal to n. And that will be the nth term of the sequence. And it's type of like, you could say the general term, right? So like the nth term is the general term, and like if we have the general term of a sequence, we can get like the sequence itself by putting the value of n as 1, 2, 3, right? So one more thing is that if all the members of a sequence are real numbers, then it is a real sequence, and vice versa. Now, for example, let's take the nth term is n to n plus minus 1 raised to the nth power, right? Now, we can get the values of this, like we can make up the sequence by putting the values 1, 2, 3 for n, right? Now, let's say this is sequence, let's say this is like the sequence G. From sequence G, this is the general term, the nth term of the sequence G. So now, like when n is equal to 1, 2, 3, on and on, right, we'll get values. So like now, wherever there's n, we're going to replace it with these values. So first, we're going to replace it with 1. So G1, right, this means the first term is going to be 2 into 1, replacing it, plus minus 1 raised to the first power. This will be equal to 2 into 1 is 2, plus, actually minus, my bad. So minus 1 raised to the first power is just minus 1, right? So minus 1 is equal to 2 minus 1 is equal to 1. So now let's go to G2 will be equal to, like, yeah, what should we do? Yeah, we can just like keep it there. So 2 into 2 plus negative 1 raised to the second power. So like negative 1 square. So 2 into 2 is 4 plus 1, because negative 1 square is positive 1. So 1 we get, so 4 plus 1 is 5. Similarly, we'll put n is equal to 3, so we'll get G3 is equal to 2 into 3 plus negative 1 raised to the third power, which is equal to 2 3s are 6. Negative 1 cubed will be equal to negative 1, so we get 6 minus 1, which will be 5. And yeah, let's just do one more. G4 will be equal to 2 into 4 plus negative 1 raised to the fourth power. So 2 4s are 8, plus 1 is equal to 9. We get the sequence G, we can say. Sequence G is equal to 1, 5, 5, 9, on and on and on. Right. Okay, so yeah, that's pretty much it for this video. This was just like a introduction to sequences and series, and we will have more videos on this, and like we'll solve questions and like learn new topics in this like you could say chapter, right, of sequences and series. So that's it for this video, and hopefully you enjoyed it. Hopefully you learned something from it. If you did, leave a like and a comment so that other people can watch it too. I mean, like, you can recommend it to other people too, please. Share it if you find it helpful, and as always, peace out.